So we're just working on page 670 in the course pack here, worksheet number 1, but we're working on problems 3 and 4. So we've just highlighted some important pieces. So number 3A says, verify that the requirements for conducting a hypothesis test are met. So our first one is random sample. And they did state that they did a simple random sample, so that's good. The second thing is, can we say that our data is independent? And that looks like I spelled it wrong, but I don't think so. And so I don't know how big our population is, but I do know 20 times my sample size, they said there were 200 students in my sample, right? Equals 4,000. And I can definitely say that my population of 18 to 24-year-olds in the US is at least that big of 4,000. Hi, Shelby. There's a minor change from my text. We're working on page 670 is where we're starting. And I'm apologizing profusely. I agreed that online was great and we decided last minute, and then after Andrew and Peyton left, I realized I didn't have my DOT camera. So we're making do. Is everybody doing okay with what I have so far typing this up? Okay, so the third thing is normality. This is kind of fun, I get to type it. So to check and see if it's normal, we have to use N, right? P, oh geez, this is really testing my, where do I do the little zeros? Okay. Subscript, superscript. It's not those. I don't know. Does anybody know where I can get the subscript of the letter? I'd love to be able to do it. If anybody can figure out how to do. Okay, well, I'm just going to put P0, oh, no, P0 and Q0. Okay, so our N is 200 students and our P0 is the 0.15. So none of the sample information is going to go into these. We have to use all of what we think is true about our population here. And then we've got 1 minus 0.15 there. So when we multiply those together, does everybody get 25.5? I'll let y'all chime in and make sure that. Yep. Okay. And gave me the thumbs up. Okay, so it says state the null and alternative hypothesis in symbolic form for the test that she is conducting. Okay, so I'm going to stop sharing. I'm going to just go to the board here. So we want to write the null and alternative hypothesis. So we have our H0 and our H1, right? And they're talking about number of students that said they read the newspaper. So they do say whether the percentage has changed. So that must mean we're talking about P. Can everybody see my, oh, it's really, let me see if I can change the lighting. That's not any better. That's not any better either, is it? Can you see down here better if I write it down here? Can you guys see that? Okay, so the H0 is always an equal to, and they said it differs. Remember what we highlighted on the past page? So this is going to be a not equal to, and then we said that they think that what's true is the 15%. So that should be our letter B. Any questions over letter B? Okay, letter C says, using the sample data she collected, compute the value of the test statistic, show formula, substitution, and result. Okay, so on the on the test statistic, if you go to your page, what did I say, 276 on your gold sheet, our test statistic is going to come out of StatCrunch, and we'll do that together here in a moment, but it's our Z0. Is it better if I write down here? It's our Z. Our Z0 is found by taking our P hat minus our P0 and dividing by the standard error of P0. And we can get that from, we're going to get this all from StatCrunch. So we'll go there and grab all this here in just a minute. But I do want you to be able to fill that out. Now, we do know our P0 is the 0.15, right? And then our standard error is going to be found by taking that 0.15 times 1 minus 0.15 divided by n, which is 200. And then our P hat, they gave us information for that. So our P hat is always our X over our N. And what's important to remember, can you see that? Okay, there's a light there. In StatCrunch, they call it our count out of our total. So when we go to put it in StatCrunch, count is our X and total is our N. And for us, it's 40 out of 200, which is 1/5 or 0.20. So this should be 0.20. I can scan in the, I can scan you some answer keys if I need to, for people to be able to write this later. Somebody just at the door. Okay. So are you with me so far? So we need to get our table, our test statistic and everything. So let's go to StatCrunch. So this is what we had for our number 1A. Okay. So the cool thing is where we went in chapter 9, we're going to go the same place. We're just going to use something different in the same piece of StatCrunch. And Lainey's not here. Okay. So frustrating when it doesn't open on the first time. Okay, so open stat crunch, here we go. So we're gonna go to stat and down to proportion stats and one sample. What proportion stats? One sample with summary. And our number of successes we said was 40 of the 200 students, right, read the newspaper every day. And we have to make sure that any of these boxes that are in gray, they have to make sure that we change them appropriately. So ours is 0.15 and it's a two-tailed, so we can leave that. Make sure everybody sees that there. Okay. And then we're going to hit compute. And there it is. So our test statistic is our z-stat. So where it says z-stats, you might want to make a note that that's our test statistic. And that comes out to be 1.98. I wanted to look at this one right here. Okay, so did everybody come up with the same value that I have there? So under wait, I was just writing, but it's gone. Under the test statistic for letter C, we're going to put 1.98. So I'm going to go back there to my screen. So right here we were. Okay, so letter C, our Z0. Our Z0 is 1.98. Okay. So that's all you have to do. I want you to fill in the formula, but do not put anything in your calculator and try to figure out and make sure it matches 1.98 because it'll probably drive you crazy. So next says perform step 4 of the p-value method. So you can see on page 276, our gold sheet, that we have a two-tailed test. And so we're going to go straight down and we're going to draw a curve that is also two-tailed. So I'm going to put that up on, I'm going to stop sharing so you can see the board again. So the picture that we're going to draw is also two-tailed. And my p-value that comes out of the stat crunch, we say that it's kind of in these two spaces. It's not necessarily divided by 2, but it is in those spaces. And that should have been 0.0477. Did everybody get that? 0.0477. Okay, and so on step 4, it's just asking us to draw that on here. So that's 0.0477. Okay. And so E says, will she reject H0 at the 0.05 level of significance? So for me on letter E, I always write my p-value 0.0477. And then I draw my alpha, and they said alpha is 0.05. And then I ask myself the question, is it less than? That's a question mark, right? And if the answer is yes, it's less than, then we do reject. So 0.0477 is slightly less than 0.05. So we do reject. Any questions so far? Does everybody have the picture okay? Make sure everybody gives me there. Everybody's okay? Anybody chime in? Okay, so let's go ahead and just type how this is going to look on here. So yes, we reject H0 because 0.0477 is less than 0.05. Okay, and so in our course pack, those pages that I mentioned last week that were really important. So let's go to those pages. Page 229 at the top. I want to make sure everybody knows where to refer on this. So at the top it says reject H0, and then we explain our conclusion as step 6 is there is sufficient evidence to support the claim, and we talk about H1. But this one is, and then down below it says do not reject H0, and then our conclusion for step 6 is there is not sufficient evidence, but we are rejecting H0. So, whoops, we can say there is sufficient evidence to support the claim that the percentage of 18 to 24-year-olds, year-olds that read the newspaper daily is different than 15%. We don't know what it is, and we can't say that it's the 20% that came out of our sample, but we can say that there is enough evidence, barely, right? It's barely under 0.05, but there is enough evidence to say that it is different. So that's our letter F. Any questions there so far?
Nope.
Okay. And actually, I'm going to go to StatCrunch and sometimes it'll let me copy and sometimes it won't. I'm just going to copy this whole thing. There. Okay. So let's go down to, is there only one page? Should be question 3, right? Or question 4?
4. Yeah.
Well, that's weird. Not in the old one. She added it, so that's okay. So this says, according to, is everybody okay moving on to the next problem, number 4?
Yep.
Okay. So it says, according to securelist.com, 78% of all emails sent is spam. A researcher from spamlaws.com believes that the percentage is higher today. They gather a random sample of 500 emails and find that 412 of them are spam. Test the claim at 5% level of significance, showing all work, steps, and graphs. So I'm not, on a problem like this, I would not expect you to show me the 3 requirements. We would kind of assume that they're good. Okay, so let's go ahead and just do our our steps. So if you can see this okay, I'm going to put them up here. Is everybody okay with that if I put them up on the screen? So first thing we need to do is we need to decide our hypothesis. So So our hypothesis statement, so a couple things that we should be highlighting, right, in our page here is that 78% of all emails sent is spam. So that is going to be, right, our H0, our P0, because that's what we think is true about our population. And then with this line where it says they gather a random sample of 500 emails and find that 412 of them are spam, that's going to be what we're going to use as our evidence later. So H0 is so P is 0.78. And then do they think it's more or less? What is the claim?
Higher.
It's higher. So that's going to be a left tail, right tail, or two tail.
Right tail.
Right. So we think it's bigger than 0.78. You all can see that?
Yes.
Okay. So then our second step is we are just deciding our level of significance. And type 1 probability of a type 1 error is the same as your alpha, which is also the same as your level of significance. They're all the same thing, just different wording. And that's 5%, so 0.05. Okay. Then step 3, we have to find our test statistic, our z-stat. And that's going to come out of StatCrunch, but we have to have some things that go in there, right? So we need X and N, or our count and our total. So our count and our total in StatCrunch. So our count is going to be how many of them had said they were spam. 412 were spam. And there were 500, right, in all. So our p hat is going to be found by taking 412 divided by 500. And StatCrunch will get that for us. So let's go ahead and find out what z-stat is in StatCrunch. Let's go get that. Make sure everybody gets a chance to do this. Okay, so H0 and H1. So I'm gonna go ahead and share my screen here. Let's go back to StatCrunch. So we're again gonna go to stat and proportion stats, one sample and with summary. And there's gonna be 412 and 500. And our hypothesis we said was 0.78. And we think it's a greater than. So does everybody see what I've typed into StatCrunch? I want to make sure everybody's good on. Shelby, Adam, Cassie, Genevieve, everybody's okay on this? I want to make sure, does anybody need help? This is the time to ask. Okay. So our sample proportion is 0.824. There's our standard error, and our z-stat is 2.375. Any questions on that one so far? Okay. Okay. So let's just write that 2.375 and my p-value is 0.0088. Okay, so we're not going to need that until step 4. So step 4 is our curve. Wow. I am really doing well on my pictures today. Let me go back in. I need everybody needs to see that. You guys, but it's pretty good. Okay. And this is a greater than, so I'm over here, right? And so I'm kind of doing step 5 at the same time because I'm going to write out my p-value, and it's right there in my curve. That's really what I want you to mark. And I have to go back and look at what my p-value was, 0.0088. Okay. So 0.0088, and I'm checking to see how that compares to my alpha, and I'm using alpha 0.05, and it's less than, so we do reject H0. Right? We do reject H0, so we do believe, right, there is sufficient evidence to support the claim that, I'm going to write this all out, and I'll send you this one since we didn't. So 6 says there is sufficient evidence to support the claim that the percentage of spam email is higher than 78%. And okay, so I'm just going to go back and check this out real quick. So our sample proportion is 0.824 minus 0.78 over our standard error 0.0185 was 2.375. Okay. Any questions so far? Okay. So both of those were reject H0. We need one that's not. So let me keep that one out. I say we go to maybe we can do that one if we get through this. Okay, page 675 is where we get to have some really good conversations on just understanding significance level, statistically significant, all of those things, and the wording. See if anybody has any questions. Right here. Okay. So I'm going to go to this worksheet right here. Oh, I'm not sharing my screen. Okay, can everybody see my screen? So I'd like to work on these true and false questions. So one thing I want to mention is that statistically significant is equal to rejecting H0. So if we were to reject H0, we are saying, yes, it's statistically significant. They're equivalent to each other. So 1A says if the p-value is equal to 0.02, then the null hypothesis is rejected at the alpha equals 0.04 level. What do y'all think? So 0.02 is less than 0.04. And does that mean that we do reject?
Yeah, it means we reject H0.
Okay, so that is a true. We reject H0. Okay. Okay, B says if the p-value is equal to 0.02, the result is statistically significant at the 0.01 level.
That's false.
It's false? And what? Why do you think it's false?
Well, because the p-value is bigger than the alpha.
Okay, so if we wanted, so we would want to show if we would reject H0, right? That's the same thing. So 0.02 is greater than 0.01. So since we would not reject H0, it is not statistically significant. Okay. Also, a few of you did not turn in your chapter 9 worksheets. So those need to get uploaded today into JetNet and let me know once they've been uploaded so I can grade them. I don't know if there's a miscommunication. Ashley, I got yours and Andrew, I've got yours. And Lainey, I had hers. But I think there were a few others, and I'm only saying that just because I don't want those people to think they've got to turn theirs in. So if you had to turn those in, or if I didn't see them, just let me know. Everybody kind of busted out the other day, and I was like, wait, what happened? Usually everybody's throwing them up on my table. So just want to make sure I get those and give you some feedback. So let's look at letter C. It says a p-value of 0.02 is less statistically significant than a p-value of 0.03.
False.
Who said false?
I did. Me.
Me, Ashley?
Yes. Yeah. Sorry.
No, that's
Sorry.
so what is your thinking on that?
Well, aren't the p-values more or significant the smaller they are? We want them smaller.
Okay, smaller the better. Okay. So I'm going to show something. I'm just going to kind of explain it like I did some morning class for those that are, this is kind of a deep concept. These are concepts that we think about on the worksheets. It's a big concept that I would love for you to take with you out of the class, actually. So if we were comparing, we said 0.02 and 0.03, right? So if we looked at alpha and we said, what if alpha was 0.01? Would we reject if alpha was 0.01 for 0.02 and 0.03?
Yes.
We would reject?
No.
Oh, no.
No, because 0.02 is bigger than 0.01.
Right.
0.03 is bigger, so do not
So
reject.
yeah.
Okay.
Okay. And at 0.01 alpha, our confidence level, right, which is the complement of alpha, is 99% here. But we're not rejecting with a 99% confidence. What if alpha was this? So if alpha was 0.025, would I reject at 0.02? My p-value is 0.02.
Yeah,
And why is that?
because it's bigger than, because the alpha is bigger than O2.
Okay, so 0.02 is less than 0.025, so reject. Would we reject for this p-value?
No,
These are my p-values, by the way. So this one is no, do not reject. Okay, and at this alpha, our confidence level is 97.5, right? So what alpha would what's an alpha that I could choose where I would reject both of them?
0.04.
Okay. And how do we choose that? What is just our requirement to find one that they both reject?
It's got to be bigger than both of them.
Okay, so it has to be bigger than both of them, or they both have to be smaller, right? So this is a 96% confident. And so we would reject on this one, and we would reject on this one. Okay, so kind of working out what Ashley mentioned earlier, sometimes it's good to kind of see it all written out to get the big picture, is that we want alpha to be as small as possible because alpha rejected at higher confidence than the 0.03 did, right? 0.02 rejected at a 97.5% confidence, but 0.03 p value did not. So the smaller the p value, the more statistically significant it is. So just what Ashley had mentioned, but I thought kind of giving us some numbers that kind of like think about and compare to. So the smaller the p value, the better. So that would be a false on 1b. I'm sorry, 1c is, they're both false, but 1c is it's 0.02 is more statistically significant. Okay, any questions on that one? Anyone? Okay, what about number 2? It says a statistics instructor gave a coin to each of 2 students. The 2 students wanted to test whether their coins were fair. So they each flipped their coin many times and recorded the proportions of heads facing up. What are the hypotheses for each student in symbols?
Start marking this back out.
So we're talking about proportions still, right? What would it be to be considered fair?
0.5.
0.5, so we're thinking 50-50. So that's one where we don't actually give you a number, so you're gonna have to read into the problem when we say something's fair, a fair coin or whatnot, or a fair die, right? If it was the rolling a fair die and getting a 3, we would assume it's 1 out of 6 would be considered fair. So fair isn't necessarily 50-50, but in this case it is because there's only 2 options. Okay, and then they don't also say if they think it's greater or less, and they just think it's just not fair. For that one. Okay. Then number 2b says The students collected their data and each ran a hypothesis test for this rolling of the coin or flipping of the coin. The test statistic for student A was 1.8 and the test statistic for student B was a negative 2.1. Which of these test statistics has a smaller p-value? Explain. So I thought it was helpful for me to draw a curve. Okay, so negative 2.1 is going to be on the left, right? And 1.8 is on the right. So which one would have a smaller p-value? So which one do we think would have a smaller p-value?
I'm guessing, so I think it's 1.8.
Me too.
I think it's this one is a smaller p-value.
Yeah, because I believe because it's closer to 0. That's my opinion.
Anybody else want to throw in an idea?
I thought the same thing Andrew did.
Okay, well, if we go to StatCrunch, we can actually, a student this morning said, well, why don't we go look at the normal curve and find the probability of each of these happening? So if you go to calculators and normal, we can actually put in, let's do the one on the left first, so we already have a left bound. We put in the likelihood of being a negative 2.1 z-score, and there's our p-value for that, which is 0.017. 0.0178. And if we do the greater than the 1.8, it's 0.0359. So it's actually the negative 2.1.
Why is that? Is it because it's like farther away?
Yep. So if you think about when we use z-scores back in chapter 3 to decide if something was unusual,
Mhm.
the further that z-score was away, right? The absolute value of z, the bigger it got,
Mhm.
the more rare it became, which means our likelihood of being weird and actually happening is getting smaller and smaller, right? Kind of like on the example where I had you watch the course pack and I said I rolled 12 5s and you're like, I don't really think that's possible, right? And then we at the introduction of chapter 10.1, I actually figured out the probability of getting 12 5s and it's just like insanely small. And so that's essentially what's happening here. So let's just kind of make a kind of hopefully some connection. So our z statistic, which is the absolute value of our z, right? When that gets bigger, I'll do them in different colors. Our p-value gets smaller. Which means our statistical significance goes up. Any questions on those so far? Okay. Shall we look at the rest of this for just a minute here? It says fill in the blank here at the bottom of page 675. And it says, if the p-value is less than the level of significance, we blank the null hypothesis. I'm going to go back to my screen here. And that's not the screen I want to be at. Okay. We're at 3. Okay. If the p-value is less than the level of significance,
Reject.
we reject?
Yes.
Okay. Reject. Oh, we should probably put H0 just so we all know, right, what we're talking about. I'm going to shade it. Okay. The smaller the p for B, it says the smaller the p-value, the stronger the evidence against the blank hypothesis becomes.
Null.
The null.
Null hypothesis.
Yep. For H0, right? We've been saying that, so let's just write H0. Awesome. Any questions on that one? This was another good one. The flu vaccine. If y'all want to do another one, we can do the number 4, the researcher. This must be a new one too for. It used to be number 5 in our old. Everybody want to go through another one? How's everybody feeling? So number 4 says, a researcher for the CDC believes that a minority of 210 million US adults received the flu vaccine during the 2018-19 flu season. To test this, they gathered a random sample of 3,020 adult Americans and found that 45.7% of them had received the flu vaccine during the 2018-19 flu season. So it says, what are the researchers' hypotheses, and verify the requirements, and then test the researchers' claims. So I say we work on this. I'll let you work on it, and then we'll kind of we'll put it together. So we're back working on page 676, question number 4. And we just verified the requirements. I'll put pictures, I'll text out pictures of these so that everybody can see what I'm writing down, but I can put it on the board as well. So part C says we've already met in part B the requirements. Part C says test the researcher's claim at the 0.01 level of significance. So we already did step 1 in part A. Is everybody cool with that? You've seen my handwriting. Trying to avoid more of that. Okay, so step 2 is the alpha, which is 0.01 level. Step 3 is our Z statistic. And we're going to get all this from StatCrunch, right? So 3 is our Z. And so they said our p hat was, they found in the sample 0.457. minus 0.50, and then we're going to get the rest of that from StatCrunch. And let's go ahead and draw our picture because we're going to need that too. And because it's a minority, it's left-tailed this time, right? So let's draw that. And we'll go to StatCrunch and just make sure it's all good. So our p-value, once we find it, is going to be right there once we find it. See? So let's go ahead and I'm going to share my screen to my StatCrunch again. And so we're going to go to stat, to proportion stats, one sample with summary. And do we know number of successes? We do? How many, Andrew? Did they tell us that?
Not exactly.
Oh, how do we find our X, our count?
We would, when we just times 0.457 by the sample.
What sample?
Our, like they gathered.
Excuse me, the 3020?
Yeah, times that by 0.457, and that's should give us the amount of successes, right?
Okay, it should. So I want everybody to see up here that our count, which is X, well, we don't know that. Remember, I think that was on page 640, actually. It was a worksheet that we brought up this morning. That is found by taking N times P hat. And so 3020 times 0.5457 is 1380.14.
Yes, correct.
So I'm going to use 1380. So it's important that you let me know what you're using, because depending on if you round up to 1381 or round down to 1380, it's going to change your t-statistic just slightly. And then this is going to be our total, which is N, which is 3020. You need both of those for your StatCrunch information. Everybody ready to put that in? Okay, so we said 1380 and 3020, and our P is 0.5, but this is a less than because it's a minority this time. And we're going to hit compute. And there it is. And I'm going to copy that and put it in. So you can see that there. Okay. And our Z statistic is negative 4.73, right? Negative 4.73. And our P value is, ooh, it's got that symbol. What does that mean? It says less than 0.0001.
Means it's a number smaller than that.
Oh, yeah. So it means that it's so small that it's less than that. So we definitely know it's less than our alpha, which we said was 0.01. So again, we do reject H0.
Yes.
Yes.
Yes, we do. So there is sufficient evidence to say or to support that there is a minority of US adults getting the flu vaccine. I'm curious, does anybody wondered this fall? I am super curious if, I know that like so many places are requiring the vaccine and blah, 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 blah. I wonder if do you think more people are now getting the flu vaccine too? Or you think people are just like, I'm not getting the flu vaccine. I got the COVID, but does anybody else wonder that? Or if they're just like, oh, I might as well just get them both now while I'm there.
I think they're skipping it.
Skipping it?
Actually, I just read yesterday the CDC is in Ann Arbor because there's such a high rate of flu right now amongst the college. Yeah.
Flu at U of M?
Mm-hmm. Yep.
Interesting. It's an interesting thing going on. So I think we've done lots of great examples. I'm happy to do question number 5 if anybody wants to do another one, unless you think you've got enough to get going. I'm happy to answer questions on the Chapter 9 project if there's still any out there. That's due tonight. I will be, I've got some projects from my other class to get to get graded for my, not my other stats class, but my other class. But then I will be starting to look at these projects for you. Anybody have any questions? Cassie, Adam, Shelby? Just gonna pause this for now.